Okay, so this is the first of our videos on applications of differentiation. So we've spent quite a lot of time now learning about the techniques for differentiation, and obviously we also have an understanding of derivative being about gradient. So we want to look at a series of applications around that, and the first of those is going to be tangents and normals. So let's have a think about what we know. So we know that the derivative of a function, we can denote that f dash x or dy dx or all sorts of other things depending on what the original function is called. But the point is that the derivative describes the gradient of the original function at any point x, y on the curve. So we get a rule to describe gradient. Okay, so we can substitute the x coordinate of the point in and it gives us the gradient. Now, a tangent and a normal. So a tangent, we're familiar with tangents before now. We talked about tangents in the initial definition of derivative by first principles. So we know that a tangent is a line, a straight line, that has the same gradient as the curve at the point of intersection with the curve. Okay, so for example in this diagram here, the blue line is meeting the red curve y equals f of x at the point P, and it is tangent to f of x because at that point P, the blue line has the same gradient as the red curve. Okay. A normal is a line that is perpendicular to a tangent at the point of intersection. Okay, so the normal will meet the tangent at a right angle. Okay, so we know about, perpendicular lines back from our, Year 10 coordinate geometry work. So it's simply about, it also goes through the point P, but we'll have a gradient that is perpendicular to the gradient of the tangent. Okay, so the gradient of the tangent to f of x at the point P, if the point P has coordinates of a, f of a, okay, well the gradient of the tangent at that point is the same as the gradient of the curve at that point, and we know that we find that by finding the derivative and substituting the x coordinate of that point into the derivative. So the gradient of the tangent to the curve at the point P will be f dash a. And therefore the gradient of the normal to the curve at that point, so we know that the gradient of the normal is going to be the negative reciprocal of the gradient of the tangent, as I mentioned before, casting your mind back to your Year 10 coordinate geometry work. And so therefore the gradient of the normal will be negative 1 over f dash at a. Okay, so we can find the gradient of the tangent or the gradient of the normal, provided we have the equation of the curve. And then once we've got gradient, and obviously we've also got a point, that point P, we needed that point to find the gradient at the point. So gradient and a point is enough to define a straight line, and so we can find the equation of a line, whether we use y equals mx plus c, or my preferred choice of finding the equation of a line given gradient and a point, which is y minus y1 equals mx minus x1, which is just simply a rearrangement of the gradient formula, except that gradient and one point are known, and it's a point that's unknown. That's xy, that's where you're getting your equation. Okay, I'll do some examples with the two versions for finding equation of a straight line. Okay, so we're going to work through three examples here. Find the coordinates of the point or points on the curve y equals 1/3 x cubed plus 1, at which the tangent is parallel to the line y equals 4x plus 3. Find the equation or equations of the tangents. Can I really encourage you in these sorts of problems where there's sort of quite a lot of information and it's very easy to potentially get a bit confused here? Draw a diagram. What's happening here? What am I actually trying to find? What am I looking at here? So the curve that we're dealing with is a cubic, dilated by a third from the x-axis and up by 1. So it's going to look something like, just, very rough sketch, doesn't need to be accurate. It's going to look something like that. Okay, and then, now I probably should have drawn that a little further down. Let me just move that down so I've got some more room. So then we also know we want to find the coordinates of the point or points, sorry I didn't mean to change the colour of that, coordinate of the point or points at which the tangent is parallel to the line y equals 4x plus 3. Okay, so y equals 4x plus 3, there's plus 3 up there, gradient of 4, I don't know exactly, but it's going to look something like that. So we want to find the coordinates of the point or points on the blue curve which are parallel to the purple line. Okay, now if you think a bit logically about it, there's probably going to be 2 points where this happens. Let's say somewhere kind of there, so that it's parallel to that, and let's say maybe somewhere kind of down here, so that it's parallel. Okay, so I mean, obviously my diagram's not to scale, it's a very rough sketch, but we are trying to find the coordinates. So again, be clear about what you're trying to find. Find the coordinates, so we're finding coordinates of these 2 points, that's what we want. These 2 red points I've marked on the curve, at which the tangent is parallel to the line y equals 4x plus 3. Okay, so if we want the tangent to be parallel to 4x plus 3, that means that we need the gradient of the tangent to be equal to 4. Same gradient as that line 4x plus 3. Okay, so we want to know where is the gradient equal to 4. So that is, where is the derivative of the curve equal to 4. So we want dy dx, which in this case is going to be 3 times a third, so that's 1x squared. It's just going to be x squared. We need that to equal 4. We can solve for x, so x equals plus or minus root 4, which is plus or minus 2. Okay, so that's marrying with what I'm seeing in my diagram. Positive 2, negative 2. Alright, now the question asked me to find the coordinates, so I also need the y coordinates of those points. When x equals 2, what does y equal? When x equals negative 2, what does y equal? And this is where, if you haven't drawn a diagram, the tendency is here for students to put these numbers into the wrong equation. Now, it would be completely unhelpful for me to put plus or minus 2 into this equation to work out y, because that would be working out the points on the purple line, and I'm not interested in the purple line, I want the points on the actual curve. So these values need to go into the equation for the curve so I can find the relevant y coordinates. Okay, so when x equals positive 2, y is going to be 1/3 times 2 cubed plus 1. So that is 8/3 plus 1, which is 3/3. So that is 11/3. Okay, and then we also know when x equals negative 2, y will be 1/3 times negative 2 cubed plus 1, which means it's negative 8/3 plus 3/3, and so negative 5/3. So obviously in my diagram, my x-axis is too low down, so that second point on the left of the y-axis should be below the x-axis. But again, just a diagram to give you a sense and understanding of what's happening. Where do I need to substitute the numbers back in? What am I trying to find? Okay. So we've got the 2 points. All right, so we've got the point 2, 11 on 3, and we have the point negative 2, negative 5 on 3. Okay, so that's find the coordinates of the points. That's the first part of the question. Then it says, hence find, or it doesn't say hence, but it could, find the equations of the tangents. So we want to now find the equations of those 2 red lines. Okay, so we know gradient and a point on each of those 2 lines, and I apologise here, I should have given us some more space. I might move out to the side here and find our 2 equations. Okay, so we're going to have tangent at the point 2, 11 on 3. We know that it has a gradient of 4, both have a gradient of 4, and goes through the point 2, 11 on 3. So personally, I prefer to use y minus y1 equals m times x minus x1 for finding equations of lines given gradient and a point. I would only use y equals mx plus c if the point that I have is a y-intercept, because then I can write down the equation straight away. Otherwise, I like that this enables me to put all the information directly into the equation. So this is the y coordinate of the point equals the gradient, which is 4, times x minus the x coordinate of the point, and then it's just about expanding out and making y the subject. So y minus 11/3 equals 4x minus 8, so y will equal 4x minus 8 plus 11/3, so 8 is 24/3, so it's minus 24/3 plus 11/3, so that's going to be minus 13/3. And so that's the equation of the tangent at the point 2, 11 on 3, and then, apologies, then the second tangent, so the tangent at negative 2, negative 5 on 3. I would do it the same way, but just for interest here, I'll show you if you were to do y equals mx plus c instead. So the thing I don't like about mx plus c is it happens in bits and pieces. So first of all, I substitute in the gradient. I know that the gradient is 4. Then I sub in the point, negative 2, negative 5/3. So when y is negative 5/3, x is negative 2, so I get negative 5/3 equals negative 8 plus c, and so c equals 8 minus 5/3, which is 24/3 minus 5/3, so 19/3. Okay. Sorry, it should have been, I guess that's right. And so then I get my equation is y equals 4x plus 19/3. So I personally, you substitute in the gradient, then you sub in the point, then you solve for c, then you put it all back together in the equation, whereas this version, you put your point and your gradient in at the same time, and you simply just rearrange it to make y the subject. So generally I find it's a bit less working. The actual math steps that happen are the same. In this question here, where we use y equals mx plus c, where we had to subtract 5/3 from 8, that would have happened at this final step in this other process. So the mathematics you have to do is identical. I just prefer the process of it. But either way, will get you to the correct equation. So the equations of the tangents, there's the two equations of the two tangents, and there's the coordinates of the points where we have the gradient of 4. Okay, let's have a look at example 2. Find the equation of the tangent to the curve y equals x minus tan x at x equals pi on 4. Okay, so we've got some kind of curve, so we need the gradient of the tangent and a point on the tangent. So we're actually going to need to do some work for both of those things before we can find the equation of the tangent. So obviously we need to find the gradient when x equals pi on 4. Okay, so we need gradient is going to be about finding dy dx. So derivative of x minus tan x, derivative of x is 1. Derivative of tan x is sec squared x, or 1 on cos squared x. And we want to know when x equals pi on 4, what does dy dx equal? So dy dx will be 1 minus 1 over, now remember that cos squared means cos of x all squared. So it's going to be cos of pi on 4 all squared. Okay, so that's 1 minus. Now cos of pi on 4, thinking about your exact values, your special triangles, cos of pi on 4 is 1 on root 2. So we've got 1 on root 2 all squared, which is 1 on 1/2. 1 divided by 1/2 is 1 times 2, so it's 2. And so the gradient of my tangent is negative 1. Okay, and then we're also going to need a point. So we need to know when x equals pi on 4, what does y equal? So we're going to sub x equals pi on 4 into our equation to find y. Okay, so we also know when x equals pi on 4, and this is why I like function notation, because f of pi on 4 is much easier to write than when x equals pi on 4, y equals. Okay, so y equals pi x, which is pi on 4, minus tan of x, which is pi on 4. Now tan of pi on 4, back to that same special triangle, is 1, and so our y value is pi on 4 minus 1. So the point, therefore, is pi on 4 minus 1. And you might choose to write that as pi minus 4 all over 4. It's up to you. Same thing. Okay, so we've got the information we need. Gradient, point, and so we can then find the equation. Okay, so equation of tangent. Just checking that it was asking for the equation of the tangent, not the normal. Okay, so y minus y1. Careful with that because the y coordinate of the point has more than one term, so just be careful that when you subtract it, you're subtracting the whole thing. So y minus y1 equals gradient times x minus x1. And now again, let's just expand out, collect like terms and make y the subject. So here we've got y minus pi on 4 plus 1 equals negative x plus pi on 4. And then we're going to get y on its own. So we'll have negative x plus pi on 4 plus another pi on 4. So that's 2 pi on 4, which is pi on 2. And then take away 1. So there's the equation of my tangent. Okay, example 3. Find the equation of the normal to the graph of f of x equals log e of 2x at the point 1/2, 0. Okay, so equation for normal this time, so we're going to need to find the gradient of the tangent first and then take the negative reciprocal to have the gradient of the normal, and then we've got the point, okay, which is an x-intercept. So, you know, noticing those things, if that was a y-intercept, the process of finding the equation of the tangent would be very simple. So thinking carefully about that kind of thing. Okay, so we want gradient of the curve at the point. That gives us gradient of the tangent at the point, negative reciprocal to find gradient of the normal. Then we'll have gradient and point, and we can find the equation of the line. Okay, so we need derivative. So f dash x, derivative of log e of 2x is just 1 on x. Remember, it's 1 on 2x times 2, so it's just 1 on x. Because you could also think about log e of 2x as being log e of 2 plus log e of x. And log e of 2 is a number, so when you differentiate it, it becomes 0, and then derivative of log e of x is 1 on x. Okay, so shouldn't need to sort of write 1 on 2x times 2. You should be able to go straight to that being 1 on x. Okay, we want to know the value of the gradient at the point half 0, so f dash at half, which is 1 on 1 half, which is 2. Okay, and so that's the gradient of the tangent, which means that the gradient of the normal is going to be 1 half. So we now have gradient and a point. There's the gradient, there's the point, and we can now find equation of the normal. So equation of the normal. So y minus y1, which is 0, equals gradient, which is 1 half, times x minus x1, which is 1 half. So it's just going to be y equals, I'll expand out the right hand side, half x minus a quarter. So there is the equation of the normal. Making sure that when you're asked to give an equation, it actually needs to be an equation. You can't just write half x minus 4. That was a comment that came through in the examiner's reports a couple of years ago. Yeah, it's not sufficient. If you're asked the equation of a tangent, the equation of a normal, you can't give an expression as the answer to that. So making sure you've answered the question. Just one quick thing to finish up here. So when you have your CAS available to you, which you often will in application questions, obviously, if you're being asked to find the equation of a tangent or a normal when you have your CAS available, it will be worth no more than 1 mark because it's a very straightforward process. And of all the things I ever say to you in this entire year, the one thing that seems to go in one ear and out the other is finding an equation of a tangent with your CAS is easy. Do not do it by hand if you have a CAS. Okay, so please listen to that this year. So finding the equation of a tangent or normal. So menu. 4 for calculus, and then down the bottom, number 9 is tangent line, and A in the menu options is normal line. So if I choose number 9 for tangent line, let's do these last 2 examples we just had here using our CAS. So if we're finding the equation of the tangent to the curve y equals x minus tan x at x equals pi 4, let's check that our answer was correct. So the first part that you need to give the tangent line instruction in your CAS is the curve that you're finding the tangent to. And you don't actually give it as an equation, you just give the expression. So we're just going to put in x minus tan of x. And that sort of seems a bit unintuitive, and I understand that completely. I'm in degrees because of my year 10, so let me just fix that or we'll be in some trouble here. Okay, so x minus tan of x is the expression. And then comma, and then we also need to tell it where we're finding the tangent, and that's going to be at x equals, and it has to be x equals if the variable in the first part is x. So if we wrote y minus tan y at the beginning, then we'd have y equals something. So whatever the variable is in your expression, you need to have that variable equal to the value at which you want to find the tangent. So in this case, it'll be pi divided by 4. So it seems a bit unintuitive that the first part you don't write the y equals, but the second part you must write the x equals. Okay, so just get used to using that, but then straight away we'll get the equation to the tangent. Now let's just be clear here, we've got the negative x. Now they've combined this bit here together. Remember that is pi on 2 minus 2 on 2, and so it's pi minus 2 all over 2, which is exactly what it's got in the CAS there. Okay, so certainly don't need to go to that point, but recognising that what we have there is the same. Okay, if you want to find equation of a normal, let's use this example here. So menu 4 for calculus, A for normal line, and our equation, so we don't put the f of x, we just write the expression bit, so that's going to be log e, so ln of 2x and comma, and we want it to be to find the equation of the normal when x equals 1/2. Enter. Alright, and we've got 1/4 minus x on 2, which is the same as, oh, we've got the negative. Ah, okay, there was a nice little check there. So when I found my gradient of the normal, I took the reciprocal, so up here, took the reciprocal, I should have taken the negative reciprocal. Okay, so it should be negative 1/2, means that should be negative 1/2, and when I expand this out, I get minus 1/2 and plus 1/4. Nice little lesson there in worth checking your work using your CAS. It gives you the CAS practice and also enables you to check that you've got your answers right as you go. Okay, so the work today is from exercise 10A. It's quite a long list of questions there. There's a lot of variety of the sorts of ways these kind of questions will be asked. It won't just simply be, find the equation of the tangent to this curve at this point. Equally, we want to give you a variety of practice around the different functions, trig functions, log functions, exponential functions, etc., etc. So again, lots of good differentiation revision here. Okay, so head off and do that work now.